is Damien Le Carpentier. So, Damien, the floor is yours.
Yeah, thank you. So, well, without any delay, I suggest we start the first session of the workshop, which will try to set the scene about what's happening in Europe. We have a new, very powerful acronym called EOSC, EOSC, which is in everyone's mouth in Europe. I'm not sure it has reached out to Russia yet, but maybe after this workshop it will have. So everybody's talking about EOSC in Europe. Every country, every research community, and another very strong acronym is FAIR, and this you are probably most familiar with. So fair data, and the two have really something to do in common, and we're trying to articulate them in the best possible way. So today we're going to look at we're going to set the scene about what's the EOSC and what's FAIR and how the two relate to one another. And we have two very interesting speakers to set the scene. And I'd like to welcome Michel Schouppe from the European Commission, DG Research, so Director General Research of the European Commission, who will give an overview of what's EOSC and how FAIR is relevant to EOSC. And right after, we're going to have a presentation, a remote presentation from Simon Hodson from CODATA on the FAIR Data Action Plan. So, Michel, if you want, the floor is yours.
Okay, thank you, Damien, and good morning, everybody. I'm very pleased to be here in such a prestigious university. First time for me to come to Moscow, so I'm very eager to discover also this place. As Damien was saying, I'm from the European Commission, DG Research and Innovation, and I'm part of a team working on open science. So today I'd like to give you a quick overview on open science, and especially zoom into what the European Open Science Cloud is about, and then explain a little bit about our activities related to the implementation of the FAIR principles, meaning findable, accessible, interoperable, and reusable when speaking about research data. Okay, so maybe we can start by a birthday. This period of time, it's the birthday of something which happened 50 years ago. I don't know if this sounds familiar to you, if it rings the bell, but 50 years ago, there was the launch of a Russian spacecraft called Zond 5. And this was the first spacecraft which did the revolution around the moon and came back to fall into the Indian Ocean. This was 50 years ago, and the beauty of this experience, which lasted for 1 week, was to, of course, accelerate the moon race, but also accelerate space technologies and space research. So where are we now 50 years later? 50 years later, we have about 1,700 satellites orbiting the Earth. So it's quite crowded over there. And part of those satellites are dedicated to the observation of the Earth observation. You have a committee of national space agencies that are meeting together, and they operate more than 130 satellites, taking pictures of the Earth in the various wavelengths existing. Why am I saying this? Because I'd like maybe to zoom in into one of these Earth observation programs, which is from the European Union. It's called Copernicus. And the central part of Copernicus is a constellation of 6 different types of satellites. I will not go into the details, but what I want to say here is to introduce the concept of big data factories. These satellites from the Copernicus program are operational. They are foreseen for the long term with tandem satellites to allow for security and safety and continuity of the mission. And if you take only the 3 first satellites of the previous picture, you have about 10 petabytes of data produced every year. So we are really now confronted with big data factories, and space is only one example. There are other examples coming from other disciplines of science. Let's take the example of physics. You might know about the LHC, the Large Hadron Collider, which is located in Geneva in Switzerland. And CERN is operating this machine. It's the world's biggest machine because it's an infrastructure with a ring of 27 kilometers where you have superconducting magnets that allow to accelerate and guide particles. And at CERN, they are so precise that they can make the collision of 2 beams of such particles in order to study what the particles are and whether what they observe is fitting what theory by the physicist is forecasting. So this is a very big infrastructure, and here again we are dealing with big data because every year the LHC is providing several tens of petabytes this time. And of course, this is a huge amount of data, and you need to have the computing capacity to process this, and to process this taking into account of the continuous generation of new data. So you cannot just be slow, you have to be fast. So this infrastructure had an impact, of course, on distributed computing infrastructure, and we have attached to the LHC the biggest distributed computing network, which involves more than 40 countries and more than 170 organizations. So this again is a second example of domain science where big data is having a big impact on how we do science today. Then you have more horizontal or generic technologies that also support big data, of course the Internet of Things, that creates up to 400 zettabytes of data per year, according to United Nations sources. You have mobile phones, about 5 billion mobile phones, and millions of applications that allow every citizen or many citizens to act as citizen scientists. So they can start providing and contributing to the science process with data they capture on their local environment. So this again, by the number of people able to do this and empowered by technology, this brings another source of big data that is still untapped today. And of course you can go on. There are also a lot of information and public data coming from governments and public administrations. There are data coming from financial transactions, data from the industrial sector, the private sector. So we are really facing a data revolution, and we have to cope with this when we do science. At the same time, we have this big disruption caused by technologies. The internet is only one example. You also have artificial intelligence, you have machine learning, you have other technologies, cloud computing, of course, and I will come back to this because I have to speak about the European Open Science Cloud. But clearly, we have moved from a web of documents to a web of people, to a web of data and information. And now we are really deep into a process of datafication and value generation. And this has a strong impact on science as well. So we are at a crossroad in terms of how we do science. We have to exploit this convergence of both big data, ICT, and frontier technologies. And this is really having impact not only in science, but everywhere, actually. So I would say that the nature of research is changing, the way we do research, but also the direction of research is changing. And if you combine these two, this raises a lot of opportunities. Also some risk, but opportunities. So let me now speak about open science. It's a system transition where we would like to maximize as much as possible the sharing of research outputs. It can be publications, it can be data, it can be workflows, codes, and so on. So open science is affecting the way we perform research, the way we share and diffuse knowledge, the way we evaluate also the outcome of research. It has an impact on how we are funding research, how researchers are rewarded, and it has an impact on how we should train future young generations of researchers for the future. Open science has an impact on the whole research data lifecycle, from the conceptualization of your research. When you set your ID, there is already some openness there. You can also confront your IDs with the other communities. It's about open data. When you start gathering your data, you need to be open as well. Then you have to analyze them, and this can be done in an open way with open codes. And then you come to the publishing, where you can also publish with open access magazines. So why do we want to promote open science? It's true that it's still a debate in the science community. Some scientists are not so much keen to go for open science. They want to keep control of their data. They don't necessarily know how to annotate their data so that these data are really understandable by other people. They are not necessarily trained or do not have the tools or the skills to make their data fair, findable, accessible, interoperable, or reusable. So it's not straightforward for many scientists, either from a cultural point of view or from, let's say, an enabling point of view. On the other way, some scientists do think that we need to have a science which is reproducible, and this is a real challenge for the whole science process nowadays. There was a survey by Nature recently saying that 70% of scientists who have tried to reproduce experiments that have been published did fail to find the same results. And even more striking, 50% of the researchers had difficulties to repeat their own experiment. So reproducibility is really a big challenge. And open science is clearly a way to improve reproducibility. It's also a question of transparency, because a lot of research is funded publicly with taxpayer money. So it's the right of the taxpayer to ask for transparency, and it's good for science. Open science is also a key element when you want to address societal challenges. We have to be more and more cross-disciplinary in our sciences when addressing specific questions related to society. Being energy, sustainable management of natural resources, being transport, being health aspects. We need to cover climate change, we need to cover things more and more in a transdisciplinary way and move out of our silos, scientific silos. So open science, of course, has also some supporters, and we try to mainstream open science in Europe and beyond. It's not that we are starting from scratch. There are already many tools, initiatives supporting open science through the various layers of your data research cycle. I will not go through the whole list, and honestly, I do not know all these applications, so I still need some trainings on open science. But I can refer, for instance, to open licenses. It's very important, of course, in fair data that the reusability aspect be there, and therefore we ask researchers to use and to specify licenses for reuse of their data and research output. So you have the Creative Commons, a series of standards that are available. Also regarding open publication, you have tools and initiatives that allow to give you an overview through digital indexes of open access publications, an overview of what is accessible on a global scale from open science initiatives. So we are not starting from scratch, but we have to provide more tools to the researchers, and we have to communicate more and more about open science. This is why in the European Commission we have an open science agenda. Of course, our aim is to accelerate the transition to open science, and I would say we have 2 blocks of priorities, 4 priorities that do relate and target the research stakeholders, being the researchers themselves, or the institutions performing research, or the institutions funding the research. And this is about rewards and incentives. We won't have people moving from non-open science to open science if we don't provide the right incentives. And researchers are very much interested to see a career development. So the way they are assessed regarding their science is very important, and we need also to develop some new metrics that will allow researchers to be recognized when they share knowledge, when they share codes and data, in addition to the scoring of their publications or the high impact factor of the magazine where they will publish their articles. So these are several issues we tackle with the research stakeholders, and then we have 4 priorities related to the research data. And that's here where I want to come in. It's about notably pushing for researchers that do provide data in a fair way, and also providing the infrastructure in Europe that will allow the European researchers to store, to analyze, process data in an easy way from their labs. So these are the priorities we are working on, and I'm going to say a few words on the European Open Science Cloud. How much time do I still have? 10 minutes max. So for the time being, we are not yet in Europe fully tapping the potential of data. First, there is a low level of awareness of the value of data sharing. So we need more advocacy in this direction. Then we have to comply with some regulations dealing with the privacy of data, the protection and the copyright rules. So this is important to find a trade-off between these aspects of data protection that are very important, and also some openness and effectiveness of research. But the other issues are about infrastructure and data. We have a lack of data interoperability, and we have quite many research infrastructures, but still quite fragmented or contained in disciplines and silos. And finally, we are lacking hardware capacity. We would like to have more capacity for computing, storage, and connectivity. So starting from this situation, we introduce this concept of the European Open Science Cloud. The idea is really to federate what we have already in Europe. We have already research infrastructure in various disciplines, and we would like to bridge them. We would like to bridge the communities, and we would like to make data much more fair in Europe. So these are the main drivers for the Open Science Cloud. So overall, what we mean is a trusted environment where people can log in, find the data they need, provide the data they have in a fair way, and compute and process those data. We have seen that some disciplines are very advanced in terms of services they can offer to their own researchers. But these services can also be very useful to other researchers from other disciplines. And that's the added value we would like to bring with the European Open Science Cloud. A typical example is the health community, for instance. They have developed tools for anonymization of data. This is very important because many medical records are, of course, having some private components. So anonymization is key in this community, and what they have developed can be uptaken by other communities. So this is just one example, but every community has its advantages, and we want to serve on those opportunities. This diagram shows you some of these domains in sciences that are already quite mature in terms of tackling the data-driven science. I gave you an example with the LHC on physics. I gave you an example with space technologies in earth sciences. The life sciences are also pretty mature in terms of coping with big data. But EOSC is not only for these three communities. EOSC is for the whole spectrum of disciplines, including what we call the long tail of sciences. And in order to do this, we have to address three layers. We have to address an infrastructure layer, which provides high-speed connectivity. We have, for instance, GENT in Europe, which provides already this connectivity. We need more of supercomputing and HPC capacity. We need more data storage made in Europe. Then we have a data and service layer we have to develop as well. The capacity to deal with big data analytics, to fuse data across disciplines, and so on. And finally, and that's not the easiest part, we need a governance layer. We have many technical solutions, but the biggest problem when you cope with such big initiatives, it's about governance. You have to have an agreement between all the stakeholders, and EOSC, by its very nature, is attracting the attention of funders, of universities, research organizations, associations, research communities, politicians. So we have to find a way to get consensus amongst these big heterogeneous groups with different interests. So governance is clearly the main issue we have to address for the time being. I'm going to accelerate a little bit. Maybe one step. In a nutshell, what will the EOSC provide? It will provide our community of 2 million of researchers in the European Union with, for instance, catalogs of EU research data funded with public money, catalogs of services to reuse these data, tools to make the data open and fair, and tools for the merge and the analysis of data in secure environment. And this can be done through a single access point, which will be the EOSC portal. So that's a kind of identity for the initiative. It's a single entry point. There is a back-end system behind, but we also imagine that many communities will want to directly plug to this back-end system in the future. So we foresee several entry points to the EOSC. This will not be the only one, but it's clearly the one that will be the most visible in the future. So EOSC is much more than a portal. EOSC is, let's say, the supply side of a policy activity in Europe, dealing with open access, open data, and open science. So we clearly want to use EOSC as a way to promote open research data. And I would say our baseline is not open for open, like, like a message. It's more about being as open as possible and as close as necessary. We have to be pragmatic. We know that we have to cope with privacy issues. We have to cope with intellectual property rights. We have to cope with, for instance, commercial interest when we do innovation and come closer to the market. So there are ways to opt out from the open data policy. But from a starting point, dealing with science, which is publicly funded, we want to defend first a position where researchers are as open as possible. Now, the fact that you are open does not mean, I have one more slide after, does not mean that your data are reusable. They can be shared free of charge, but if you don't annotate them rightly, if you don't describe them, provide them with clear metadata, then it cannot be reused. So data management is a key issue, and our way to see data management in the future is through implementing the fair data principles. So at the time being, for the time being, we have principles, but we are not yet at the level of implementation. And there are many existing groups that are developing the concept on how to implement fair data principles. This is very good, but we also need some convergence. We need to provide consensus between these groups. We need to clarify definitions, because each of these attributes of fair data are not binary situation. It's not findable or not findable. Usually you have a continuum of situations. So it's not so easy to be in a binary way. You have really to dig in and describe in more details how close you can be to a fully fair situation. And I'm sure the next speaker will further detail these aspects in his presentation. So our main priorities in the coming years are first to have a fair data action plan, and I think we are very close to have such an action plan released, probably next month. And from this, we can go on with developing fair data maturity models that will allow, for instance, researchers to self-assess how far their data are fair. And if they are not fair enough, what would be the recommendations to them to help them to upgrade the fairness status of their data. We would like to work on fair data certification schemes, because we see the importance of certified repositories from which then you can really work out data with trust. The issue of cost of fair data is also very important, because many people are hesitating to move to fair data because it has a cost. It has a cost in time, it has a cost in money. So it's also a question on what's the cost and who will pay for that cost. Training is an issue we want to focus on in the future with the development of curricula that could be used to train young scientists. And through EOSC we will have annual work plans. So all this is to come soon, at least in the next 2 years. We have a major launch event of the European Open Science Cloud, which will be organized in Vienna on the 23rd of November. This is a political event which will really mark the start of the implementation of EOSC. So far we have been developing the vision, we have been consulting widely the scientific communities, and we have been engaging with those communities. But the real implementation will start on the 23rd of November. Last slide. I'd like also to speak about international cooperation. Of course, what I presented is very much European-centered, and it's true that EOSC has a pan-European focus. But clearly, when we speak about fair data and open data in science, this has a global scope. So we are really looking for collaboration with our partners in research outside the EU. There are already existing global fora where we could reach and consolidate consensus on fair data implementation. And I'd like to mention one, which is the Research Data Alliance. If you don't know RDA, it's a group of 7,000 researchers. It's very much bottom-up, and it's a very good way, an international context to build consensus within the community from a bottom-up point of view. We would like to develop close ties to other initiatives in other parts of the world. We know that initiatives like EOSC are also developed in Japan, in Australia, in the US, and so on. So it's important to allow for synergies across these regions and initiatives. And we will see in the future whether we can also extend EOSC to those federated networks. Now, in the future, I also like to mention, in addition to RDA, where Russian scientists are much welcomed, we will have an EOSC stakeholders forum, which will allow also to consult the scientific community at large, and I think we would very much welcome participation from Russia in future stakeholders forum. It's very important to get also your views in the development of the EOSC. So with this, I'd like to thank you for your attention, and we have a day which is not too cloudy today, so we are happy.
Thank you, Michel, for this enlightening talk. Are there any questions?
Please, the first question, on international level, are there some attempts to make some structure that would control efforts on fair or on EOSC, first of all on fair, all over the world, for initiatives in USA, in China, in Europe, they make some different solutions what should be. So there is a need to have somebody who can control and to make some common decision. Are there any attempts to make such a group who can control maybe RCDI or?
Sure. We are working in the G7, G20 contexts, and as well with the OECD, where there is a working group on science. So from, I would say, from a more formal and country perspective, more top-down, I would say OECD and G7 and G20 are the organizations and the international initiatives where consensus can be built. But as I said before, it's also bottom-up, coming from the research community, and their initiatives like RDA, CODATA, I think will be mentioned as well, are good, very good initiatives to build an international consensus.
One more question.
Yes.
You presented 7 positions on how FAIR is going forward. First, the application plan. The second position was maturity of data,
Yes.
and etc.
Yes.
I know the document, initial document that was prepared in June for application plan. It was the first initial version. The final version is supposed to be done in November.
Sure.
On maturity, do we have some kind of documents to look? My question is based on my reason is I'm representative of microbial culture collection community of in Europe called PIRI, and we should follow all these decisions. So it's very good to see what will be the next steps. Do you know the documents on maturity or on other levels just to follow them?
Sure. I think that Simon Hodson will give you more details on the content of the Fair Data Action Plan, that he's one of the co-authors of this plan. So he will provide you with with an update on the recommendations that will be the main elements of this plan. Now, on the specific issue of data maturity models, from the Commissioner point of view, we would like to create a new working group under the RDA premise that will tackle this specific issue. The next RDA plenary will be in Botswana in November, and on that occasion we hope to launch this new working group. So if you are interested in the topic and would like to join this group when it will have been settled, do not hesitate to contact me. I can put you in contact with the lead of that group. But it's an international group, it's not a European one.
Okay,
Let's be clear.
So we should follow.
Yes.
Another question, yeah?
You cannot say about the trust and the data quality control. Does it mean that there is no problem with these tasks in your approach, in approach of open science?
No, data quality is very important, of course. It's essential.
Nothing.
Maybe that's a mistake in my presentation. No, data quality is a major issue because usually when you search for data, especially open data, you can get a lot of stuff. But when you start working with those data, you don't know the quality, you don't know the provenance of the data, you don't know exactly how it has been acquired, and in the end it's not fit for your purpose and it's not reused. So that's part of the FAIR concept. The way data will be enriched in terms of metadata, that's part of the FAIR concept. So, of course, the FAIR concepts are at a high level, so they will not tell you exactly how to document a specific data. I mean, if it's a space data acquisition in the optical domain between this and that time, every quality will depend on the domain from which it comes from. That's obvious. But the FAIR data principles will remind you as a researcher that you have to address this and this and this aspects. Don't forget to use the right vocabularies or semantics, and so on. Again, I think Simon will go into details, but it's covered by the FAIR concept.
Yes.
One last question, maybe? If not, then we'll move to the next. Thank you very much again, Michel. And we'll move to the next talk from Simon. So Simon, who was chairing, we have high-level expert groups in Europe, set up by the European Commission, bringing a set of experts to tackle a specific issue. And Simon was chairing the high-level expert group on FAIR data. So he will present the results of the interim report that they have released, if I remember right, in June of this year.
Okay, Simon, are you with us?
Yes, I am. I think that cut just when I started sharing my screen. Can you hear me now?
Okay.
Yes.
Is it loud enough, or should we?
We can see your screen.
Can you see my screen?
Это в браузере приложение.
You should be able to see the title slide of my presentation.
Just a moment.
Yeah.
I would like to make it full screen. It should be done in the browser.
Simon, we're trying to make the screen bigger to enlarge it.
Okay.
I think
I think that's fine. Yes, that's fine.
I think you probably just need to resize the window rather than, I'm not sure there's a full screen button.
It should be okay now. It should be okay now. It's relatively small, but it's okay. So
Can you resize it?
no, I think that's the best we can have, but that's fine. That's fine.
Okay.
So
Okay. You're the best judge of that.
the floor is yours.
But I take it you can hear me okay?
Yes, we hear you well. And here you go.
Okay, thank you very much. Good morning, everyone. As noted, I'm Simon Hodson, Executive Director of CODATA, and I was the Chair of the European Commission's Expert Group on Fair Data, and I'll talk, as Michel said, about that work and give some indication of the Fair Data Action Plan and the content of that report. I'm very grateful for this invitation. I'm very sorry for not being able to be there, but there's various reasons that I wasn't able to travel, which I'll not go into. But some of those are medical, and I had a meeting with the ophthalmologist yesterday. So, but my apologies. I'll give a very quick introduction to CODATA, and I'm grateful to Michel's and for the opportunity to listen to Michel's presentation, because there are a number of hooks upon which I can attach what I'm about to say, both about the context to this, about the role of international organisations, and about the content of the Fair Data report. I represent CODATA, which is the Committee on Data of the International Science Council. CODATA works in these three areas. We develop principles, policies and practices, and we've produced a number of reports over the last few years on open data, open science issues. We work on the frontiers of data science on issues to do with specifications for data. We've had a working group over the past few years on specifications for nanomaterials data. We're just launching a big initiative with our parent body, the International Science Council, on data interoperability and integration for interdisciplinary international research programs. I won't go into that, but there's more information on the CODATA website. We have a journal, the Data Science Journal, and we organise regular conferences, including CODATA 2017, which took place in St. Petersburg last October, actually exactly a year ago. And that was organised with our Russian member organisation, which is the Geophysical Centre of the Russian Academy of Sciences. Something that we're very keen to do is extend our collaboration within Russia and with other disciplines and subject areas in the Russian Federation. And as has already been mentioned, the next Research Data Alliance plenary and the co-organised with CODATA, the World Data System, will be taking place in Gaborone in Botswana in about a month's time, 4 weeks' time. And we also do a lot of work on capacity building and training in data skills. I'll mention that in the context of the report, but it's worth following up some of the information again on the CODATA website in collaboration with the Research Data Alliance. Again, we have a set of short courses in what we think are core data skills that all researchers need, and that may be of interest. I wanted to also mention our institutional context. CODATA is part of the International Science Council. That's an entity which used to be known as ICSU, the International Council of Scientific Unions, but in July this year merged with the International Social Science Council. That may seem very remote, and the merging of two international organizations, what does that mean? What it means is that the organization that represents science internationally, that is in some senses the United Nations for science and represents science in the UN system, now formally is merged with the Social Science Council and represents all areas of scientific evidence-based research. And that, in our view, is a good thing, and it affects the CODATA mission, and it means that we have increased remit to look at social science data and to look at the interoperability of data across domains, which is extremely important and is one of the things that the FAIR data principles seeks to address. And there's the information, the flag for the International Data Week. As I said, International Data Week combines essentially two conferences, the Research Data Alliance Plenary Conference and a conference called SciDataCon, which is organized by CODATA and the World Data System. Russian participants do not need visas to go to Botswana. It's only 4 weeks away, but there's still opportunity to register and to be there, and it'll be a really fantastic event, and there's more information at that website. I'm pleased to say that as of this morning, we have 575 registrants. So that's looking very good for a conference on these topics organized in Africa. So we're very excited. Okay. Some of the background or the context to why organizations like CODATA are interested in these things and why we come to this from a very international perspective. I'm now going to start transitioning onto some of the context and the background to FAIR data, and I recognize that some of this has been covered already by what Michel has said. So I will just stress here what I think are the three major arguments in favor of open science, in favor of the sharing of research data to the greatest extent possible, and we need to take on board what Michel said about as open as possible, as closed as necessary, and why FAIR data is an important and fundamental contribution to that discussion. Michel already mentioned the issue of transparency and reproducibility. Good scientific practice depends upon communicating the evidence. This is one of the major arguments in favor of the availability of data that underpins scientific publications. Indeed, it can be argued if you don't share your data in such a way, if you don't provide the evidence for your conclusions, you're not really doing proper science. And there has been a recognition over the past 20 years that this is essential and that our science systems need to catch up with the digital revolution and make the availability of large amounts of digital data more easy to achieve. Science needs to be reproducible and it needs to be transparent. The second major argument is that we can see historically, again in the past 15 to 20 years, that certain research areas have leapt forward. They have made huge strides, and much of it on the basis of the availability of data for analysis, for large-scale analysis, and for analysis by machines. And that has depended upon protocols which encourage data sharing, and it has depended upon protocols which ensure that the data is adequately described, that it follows certain standards and specifications, and that it can be integrated with data sets across the world. This has transformed genomics, crystallography, areas of Earth system science, areas which use remote sensing and satellite imagery. So one of the things that is part of the open science movement and which FAIR data contributes towards is this analysis of data at scale. And also, as Michel mentioned, there is a belief for which we can provide a certain amount of evidence that open science, the open availability of data, benefits society as a whole. It is not just in the universities and research institutes that science happens and that the uptake of scientific findings happens, nor indeed that the use of data created by scientific research or other activities can be used. We need to broaden the groups in society, enterprises, associations, not-for-profits, for-profits, that have access and effectively use the data outputs of government-funded research. And this is one of the objectives of open science and fair data as well, to foster innovation and scientific discovery. These realizations have led in the past 15 years at least, if not a little longer, to a major policy push internationally for the adoption of open research data. And I realize I've used an older version of this slide, which is largely based upon North American and Western European examples. However, to that list there, we can add that in 2012, the Indian government developed an open data policy, and in 2014, an implementation plan. There's still a long way from realizing that, but they have that on paper and they have those principles. This year, in March 2018, the Chinese State Council published a law requiring the effective management of research data. And that law goes into detail in the protection of what needs to be protected, the good management of all research data, and the sharing of what can be shared. So they're clear advocates there of open data. CODATA with other colleagues will be organizing a conference probably in October 2019 in Beijing to reflect upon the international context of research data policies and exploring the mechanisms for their adaptation. So this is genuinely a global movement. It's worth saying in Latin America as well, in Chile and Argentina, there are similar laws on the open availability of data produced by publicly funded research. As a brief preface, I think it's worth mentioning as well the incredible complexity of data which is created by science and is used by science. We talk often about big data and the way in which we can use machine algorithms to extract information from large data sets and diverse data sets. But we should not neglect the existence of small data, medium-sized data, and the incredible value of well-annotated, well-described, handcrafted data sets. Everything we can use to increase the extent to which machines contribute to the description of data sets and to the creation of metadata is a major breakthrough, but we should not underestimate the challenges. Nor should we underestimate that in many areas, the major challenge, despite all the figures that we talk about of the increased volumes of data, the major challenge is sometimes still the lack of data and our need to collect data in relation to various scientific issues. There is great complexity there. The fair data principles do a good and excellent job in identifying core principles, but we shouldn't neglect how complex the data situation is, how much work is involved, and to what extent the fair data principles need support from ancillary guidance and, from additional guidance. And really that's what we're trying to do in the Fair Data Action Plan. So I'll transition now to what is fair. And I think we can encapsulate that in this as a set of principles, and minimalistic principles, that are easy to understand and easy to communicate, that describe the attributes data need to have to enable enhanced reuse by humans and machines. And it's important to mention both of those. FAIR did not come out of nowhere. You'll have seen on one of the previous slides that I mentioned the OECD Statement of Principles and Guidelines for Access to Research Data, which is really a foundational and incredibly influential document. It is that document, prefaced in 2004 and then published in 2007, which influenced a lot of the open data policies which were adopted by research funders in Europe and North America and then elsewhere, as I've mentioned. And subsequently, there has been an attempt to stress that it's not just enough to make data openly available. You need to do certain things to it to increase its value, to make it usable. And there's been various attempts to encapsulate those principles, of which FAIR is the most concise, the most easily communicatable, and has been widely adopted. So I think FAIR, building on these previous statements, nevertheless made a breakthrough because of the ease of communication, and that it did succeed in capturing really what is the essence of what needs to happen to research data in order to make it communicatable. And people have gone through already, I think, these definitions and what FAIR stands for. So the expert group that I chair was set up by the European Commission with these core tasks. There's a number of ancillary tasks which are listed there, but the most important was to develop recommendations on what needs to be done to turn the FAIR data principles into reality. So we need to remember that the FAIR data principles are they're principles, they're touch points, they're things we reference. But in order to make them reality, we need to flesh out the actions required by various stakeholders, and we need to give additional guidance on what it means to make things findable, accessible, and above all, interoperable and reusable. And we were tasked to develop a FAIR data action plan by proposing a list of concrete actions for stakeholders as part of the final report. This is the membership of that group. So it involves a number of experts from various European countries that have been involved in a number of activities. I'll mention, of course, Peter Wittenberg, who was one of the key figures in the origins of the Research Data Alliance and has been involved in the organisation of the Wokshop, which I'm speaking in, and unfortunately wasn't able to travel, but I'm sure you'll hear from Peter later. I should also stress that the report has very much been a team effort. Really, everyone on that group has contributed a great deal to the report, but I do need to mention that Sarah Jones, as rapporteur, has effectively acted as a co-chair to this group. This is the timetable that we find ourselves in. The interim report was published at the European Open Science Cloud Summit on 11th of June, and there was a stakeholder workshop at that event. And then we have held a consultation, an online consultation, on that interim report. And we have received feedback, which we're working on, and we're working as we speak on revising that report, which will be published in November and launched at the Austrian presidency event on the 23rd of November. So that's the timescale where we are. And I'll give you, at the end of the presentation, I heard the questions, I'll give you the links to the interim report. The report will not change dramatically. It will not be a completely different document, but we are working to respond to some of the feedback that we received and to try and make the report a little bit more concise. So for the remainder of this talk, I hope I have about 10 or 15 minutes left. I will run through some of the key principles and concepts. I'm not going to list the actions in the action plan because, as I say, we're working on that. But I will try to outline some of the key areas in which we make recommendations and the key content that won't change. Something that I think we did quite nicely in the interim report and action plan was to categorize the actions into 4 steps, and I think this will largely remain in the report. So, define and apply FAIR appropriately. I think it's less possibly about definition than making clear what additional actions are needed to support FAIR. and above all, to develop and support a sustainable fair data ecosystem. And I'll talk about that a great deal. That's one of the key steps. What does that ecosystem mean? What does it contain? Ensure that fair data and certified services exist to support FAIR, those key components of the ecosystem, and to embed a culture of fair research practice. So I think 4 key steps there. It is important to discuss and understand the relationship between fair and open. The originators of the FAIR principles were very clear that fair does not necessarily in itself imply open. It is indeed important that any data that needs to be protected should also be fair within the organization which has access to the protected data. Fair is a good set of principles even where data cannot be shared. However, the FAIR principles necessarily have an intimate and close relationship to principles of open and open science. So to promote open science and take maximum advantage of the opportunities for reuse, the FAIR principles need to apply, and they need to be supported by additional policies which clarify the appropriate limits of openness, what can be shared and what must not be shared, that also speak about accessibility. When a researcher accesses a data set, how do they know that this has sufficient quality, that it pertains to their interests, that it speaks about long-term stewardship, about timely sharing, about data selection and legal interoperability. And these are areas which are, you can in principle argue that they're in principle contained within the FAIR data principles. But to genuinely be understood and to be implemented, they need considerable further expansion. And FAIR needs to be supported by this ancillary principle which supports open science, which is that data should be as open as possible and as close as necessary. A key feature of the interim report and of the final, what will be a key feature of the final action plan, please ignore these numbers because they may well change in the final action plan, is this idea of a fair data object. This is intended to communicate that we are not concerned, and we cannot just be concerned with data as such, with the core bits. In order to be fair, those data need to be closely associated and linked to persistent identifiers, to the code, the algorithms or other software that were used to create them and are necessary for their reuse, to any standards that support their interoperability, and to any metadata that provides contextual information or provenance information without which the data cannot be understood and reused. So when we talk about data being fair, when we talk about data being reused, we need to understand that what that means, in fact, is the data associated with these other pieces of information or data. And for fair data to work, for open science to work, we need this ecosystem that supports fair data. And that comprises a number of things. It includes data management plans, which provide key information about how data will be created and looked after in the long term, and essentially are an important and essential resource for the provenance information that I've talked about. We need those persistent identifiers so we know unambiguously how the data can be found, and that this data set is different to this data set. We need policies that define and regulate this, and we need standards and specifications which are fundamental and essential to interoperability and reusability. And I think it's worth saying that it's in the areas of interoperability and reusability that we will find the most challenges in making the fair data a reality. And we also need an infrastructure of fair data services, including those repositories and institutions that look after research data and the ancillary information in the long term. This vision of a fair data ecosystem is absolutely fundamental and crucial to the realization of fair data in the long term. It is arguably the core message of the report and the action plan. I'm going to skip over this slide because I think I've mentioned enough of this, but this really lists some of those elements of that fair data or that fair data ecosystem, and it's there for reference and further information. And it includes various sorts of digital object identifier, whether that's for institutions, for funded projects, for researchers, etc., which create this web of information, and the metadata standards and ontologies, which are essential for interoperability and reusability. So that ecosystem needs to be funded in a sustainable and strategic way. And without that, we cannot achieve these objectives. And it is worth saying and worth stressing that we need to consider that fair data ecosystem as important a component of the scientific enterprise as journals and the publication of articles. We cannot do 21st century science without that fair data and ecosystem, without those fair data services, without the services that look after data in the long term. We increasingly need to move to a world where we look at research infrastructures and consider them as part of the overall cost or the overall equipment needed to do effective science. And of course, we need to apply metrics to ensure that we're spending the money in as a strategic way as possible. I do not want to give the impression that findability and accessibility are definitively fixed, but relatively speaking, they're easier to provide than issues of interoperability and reusability, as I've already said. There are major challenges still in making data, even within a given discipline, fully interoperable, and certainly across disciplines. And we need to remember that many of the great grand challenge research issues of our time, the global challenges, whether that's the changing climate, whether that's our understanding of disasters and their impact, whether that's the growth of cities, whether that's agriculture, etc., etc., etc. All of those areas require data from many different sources, and all of those areas require that we address issues of interoperability and data reusability. The development of specifications for data is a core activity in many disciplines, but it's one that's relatively speaking underfunded and badly coordinated. We have a proliferation in some disciplines of minimal information standards and competing specifications, and in some disciplines we do not have the specifications that we need. So focusing effort upon interoperability frameworks. So I'm getting echo there, is something that needs to be addressed in the action plan. We can learn from what other disciplines are doing, and in terms of reusability, there's considerable value in things like the OAIS reference model, which provides high-level recommendations for the sort of information that needs to be included with research data such that it can be looked after in the long term and made reusable. I'm going to speed up a little bit so that we've got some time for questions. We mentioned metrics for data and service, which I've already covered to some extent. Science is an international and community endeavor, and we have a number of metrics for scientific contributions. It is absolutely essential that those metrics be adapted to include the contribution that scientists and research groups make by making their data available, and we need to be able to assess to what extent those groups have conformed to the requirements of the fair data principles and other requirements about as open as possible, as closed as necessary. Without such metrics, and without including that fundamentally in the culture of research, we will not achieve the objectives of open science and of the breakthroughs of the 21st century data sharing and open science offers. I've already mentioned data management plans, but these are an important feature of the recommendations in the action plan. They're not just a bureaucratic activity. Conducting research, looking after data, making sure that the data and other outputs are effectively managed is a serious undertaking, and it's an undertaking of considerable importance. In order to achieve the culture of change and in order to deliver those data, we do need to develop the practices within research groups, and we do need to document the data that we create and how we're going to look after it. The network of digital repositories has already been mentioned and was stressed particularly by Michel. Again, we need to professionalize that process, professionalize the process by which we look after research data. Too much research data is looked after in research groups in an ad hoc way and is lost when the postdoctoral student leaves or when the departmental server is changed and is never genuinely made fair such that it can be reused and is lost to humanity and the future of science. We will look back on these decades and consider the transition from analog to digital data, and consider in our inadequate management in the early years of the digital revolution of digital data, quite how much data was lost through inadequate management and through inadequate processes in research institutions. This is something we need to address and that we need to professionalize, and standards for data repositories are a way to do this, to ensure that data repositories have a particular mission, that they have the proper processes, and they have sustainability plans. Quartus Seal is a basic standard in that area. The interim report made very firm recommendations for trusted digital repositories and recommended the adoption of a Quartus Seal. We received some pushback on those recommendations, and we may soften them a little bit, but we would still argue that any new development of standards for data repositories should clearly state what the justification of that new standard is and why it does something that Quartus Seal does not. And we would recommend rather that the community focus on improving Quartus Seal as a basis for repository, basic repository certification. Finally, I think I've got 2 slides on the content left. We need to address skills and research culture. Again, the world has been transformed in the last 15 to 20 years, and we're finding in our institutions that both researchers and those staff that support research activities need to develop skills in relation to data. The report classifies those into 2 categories. What we might call data science skills, those skills to do with the analysis of data, which are part of the armory of researchers and need further to be developed, and often supported by data science experts or statisticians in certain research fields, and a sometimes neglected set of skills, which we call data stewardship. Those skills which are necessary to look after data in the long term, which understand how data is annotated, understand how file formats work, understand how those file formats can be transformed in order to ensure long-term preservation, etc., etc. Those people in research institutions who, as part of their job or as their full-time job, have the role of looking after the data assets of that research institution. And there's need for considerable attention to both of those broad areas of skill sets. And finally, the recognitions and rewards and the need to develop that research data culture, that culture around fair data and fair data sharing. We need to ensure that we, in the scientific system, that we will reward not just the publication of research articles, but also the entirety of our contribution in science, which includes data, which includes making research data fair, which includes sharing code and all the ancillary information which makes data reusable, which makes science transparent and reproducible. So I mentioned the interim Fair Data Action Plan and the interim Fair Data Report were available. They're available at those addresses with those DOIs in the Zenodo repository. They can be consulted. Please bear in mind that they're the interim report, they're not the final report, but they're a public document, and they're a very good guide to what will finally be in the final report. So that's it. I hope that's given a reasonable overview of the origins of this activity, the remit of the expert group, and the core content of the report and the action plan. Please watch this space. The final report will be launched at the Austrian presidency event on the 23rd of November. And thank you for your attention. I'll be very happy to respond to any questions.
Thank you, Simon. Thank you for this very nice introduction on FAIR and the FAIR Data Action Plan. I'll open the floor for some comments or questions. Yes?
Repository should be trusted.
Yes.
And recommended certification community is co-trustee.
Yeah.
I found address of this community, but this website is not operational.
All right.
Could be propose some other address?
Yeah. Okay.
Could we study?
Simon, did you understand the question?
So, some further information about Courtrassil,
yes.
And that the Courtrassil website wasn't operational.
Exactly, or at least the one.
Yes.
I checked
that
it just
yeah.
now.
So I'll give, yes, so I will write to the people behind Courtrassil and tell them to make the website. I'll check that anyway. Courtrassil was developed as the result of an RDA activity, a Research Data Alliance activity. It brought together two previously existing standards for data repositories. And by standard in that sense, I mean a standard more along the lines of an ISO quality standard. What Courtrassil talks about is the set of processes which you need to have in your institution or data repository to ensure that you're performing your activities according to good practice. So it means having a clearly defined mission, a process for the appraisal and selection of the data that you look after. That's called a collection policy. Processes for ensuring that the data is looked after effectively, that any file formats are changed when they need to be changed so that the data can be reused, to ensure that you have adequate metadata, that you're following standards for that such that the data can be interoperable and reusable. Because of the timing, because of the dates, they don't use the FAIR language, but in essence, everything that is contained in FAIR is included in Courtrassil. But fundamentally, what it talks about is not the data as such. It's not data-centric, it's repository-centric. It's about the professionalization of those organizations that look after data. And that's why we consider it's important. It brought together two previous standards, one called the Data Seal of Approval, which was primarily developed by Data Archives and Network Services in the DAMDID in the Netherlands, and a similar set of guidelines which were produced by the World Data System, which is CODATA's sister organization and falls under the direction of the International Science Council. Through negotiation in the context of RDA, they developed a unified standard called CORTRAS-CIL. So the reason why that's important is it's our current best of breed as a basic standard for what repositories do and how they should ensure that they're doing things according to good practice. There are other standards which are more demanding. There's an ISO standard on data repositories. But as an entry-level standard, CORTRAS-CIL is what we currently have. Doubtless, it can be improved. Doubtless, there's a need for a change of language to adopt the fair data principles. But as a current recommendation, we think that any institution, and certainly any institution that is primarily a data repository, should look at CORTRAS-CIL and should work towards getting that accreditation. And any organization that feels that CORTRAS-CIL does not meet the requirements of the fair data ecosystem should contribute to the further development and improvement of CORTRAS-CIL, or if they feel that they need to develop their own standard, should clearly say why and what gap it is that they're filling. I think internationally and in Europe, we do need to avoid the proliferation and duplication of standards of that particular nature.
Thank you, Simon.
Sorry that was... Yeah.
Okay. Any other question? So now everything is clear about EOSC and FAIR. We have two marvelous talks, and the rest will be just a further iteration of what has been said by the two introductory speakers. So, well, thank you for this first session. Thank you, Simon. Thank you, Michel. And I think...
Thank you very much. And you have my contact details, and I'll be happy to respond to any further questions on issues of training or standards. And we hope that at a high level, the report and the action plan will give guidance on how to take FAIR one step further.
We'll do that. Thank you, Simon. There's Peter saying, can you make organizer again? So do you want to speak, Peter, or?
Simon, can you make me the organizer again?
Yes, okay. Yeah.
Yes, I can certainly change presenter.
Yes.
And I think to make you organizer, I have to leave the meeting. But I'll do that now anyway, because I need to go on to another meeting. So thank you very much, but I'll leave the meeting now and make you the organizer.
Yeah, okay.
Yes, you're an organizer, Peter, now. We were just heading for coffee break. Is there something you want to say, Peter?
No, I will take care of my voice. And I will come later.
All right.
Right.
We'll take care of our voice too with a coffee now.
Yeah.
Yes. Okay, so we'll be back in 15.
Thank you, Damien. Thank you a lot for chairing this session. So, a couple of organizational questions. First, good news are that we are not forced to move to another auditory after lunch. We are staying here till the end of the day. That's nice news. So now it's time for coffee break. So I invite you all to the coffee break. It's organized on the second floor, right over the registration desk.